Okay, welcome to day 2 for credit 10. You're going to watch the video on completing the square to solve quadratic equations and answer these questions. And then we jump on to more questions about completing the square. And you come to using some algebra tiles. So you can use algebra tiles. You probably don't have enough in some of these. So you can think of this as x squared minus 10x's So you're going to take half of 10, right, is 5, so then that would separate like that. So you're going to have x minus 5 times x minus 5, and then negative 5 times negative 5 is positive 25. So you want to turn this into a positive 25, so you're going to add 2 to both sides. So then you have, this is x minus 5 quantity squared is equivalent to that expression, x squared minus 10x plus 25 equals 2. And then you square root both sides, so you get x minus 5 equals plus or minus the square root of 2. Right, square root both sides. And then we add 5 to both sides, so you get x equals 5 plus or minus the square root of 2. So you do that and those two others. And then you're going to watch a video on solving quadratic equations using the quadratic formula. So the quadratic formula is, actually it's down here, but another way that you might see it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And one helpful way to memorize this is singing the song to Pop Goes the Weasel. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So if that helps you, you can use it. So you're going to solve some equations just using that quadratic formula. So the way that I usually like to do it is actually write down what is my a, what is my b, what is my c. So a here is 2, negative 2, negative 12, and then you're going to plug those into the quadratic formula down here. So wherever you see a b, you're going to put negative 2. So negative, negative 2, 2a is 2, so negative, negative 2 is positive 2, 2 times 2 is 4, so this is 1/2, and you can do that all there. And I like using these placeholders because then you're a little bit better about keeping track of the signs. So if it's negative 2, that's b. Then when you square it, negative 2 times negative 2 is positive 4. So it helps you keep track of your signs a little bit better. So I really recommend writing down the formula with placeholders. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, and then write down your a, your b, and your c, and then plug them into those placeholders and come up with your solution that way. And then go ahead and graph it. So what are the solutions? The solutions are the values that are the x-intercepts, right? Because when this function is equal to 0, that means the function is equal to 0, you are on the x-axis. So you can find those two solutions for x will be the points on the graph. And they may, you may end up with a square root at the end, so you might have to plug it into your calculator to find out an approximation of that. Okay. And consider these related quadratic equations and see if you can, without graphing them in GeoGebra, actually pick out which ones are which. Yeah, look back at the quadratic. So the quadratic formula has some unique things about it. Remember this negative b over 2a. This part represents really kind of the center line. So if you had something like that, the center line of the graph is this x value equals negative b over 2a. And then the interesting thing is that this part, the square root of b squared minus 4ac over 2a, that discriminant divided by 2a, that is the distance along the x-axis that you would go to get to the x-intercept away from negative b. So remember it's negative b over 2a plus this, so that's plus this, and then negative b over 2a minus this is that same distance going in the other direction, and I kind of drew it out of scale, but that's the other x-intercept. So this is minus the square root b squared minus 4ac over 2a, and this is plus the square root of b squared minus 4ac over 2a. So that's something I think that's kind of interesting about this, and it kind of brings the whole thing, puts the whole thing together into a coherent whole, right? So you're matching the algebra to the geometry, and you can even put numbers to it. So it's kind of neat.